So I think everybody knows me, Sean Cleveland, Associate Director of Cyber Infrastructure. I'm going to talk about Jetstream2, next generation of cloud computing that is an NSF funded project. We currently leverage it in the climate data portal. So we are using this cloud infrastructure for processing and acquiring data for the climate data portal. If folks remember from a while ago, we have the example of the precipitation mapping workflow where we took all the codes that Tom and his team developed to take data from the acquisition all the way through to interpolated maps, containerizing that whole workflow, and then deploying those containers either within Tapas or within Jetstream. And so we've been deploying some of these things in Jetstream to leverage this. So Jetstream2, the whole tagline is AI for everyone. It's a system designed to be super user-friendly for researchers to spin up these virtual machine computing resources in the cloud. Serves academic communities that don't have those kind of resources locally. It provides a flexible environment for researchers to take advantage of cloud native approaches. It's got a number of different ways to interact with the infrastructure. I'm going to show you the easiest one here that only takes a couple minutes to spin up a virtual machine and start doing things on it. It's also available for education, so it's encouraged to be used for courses. So if you need to have computing infrastructure for your courses or long-running things like Jupyter Hubs or RStudio things for your classes, you can leverage Jetstream2 to do those things. So here is kind of a summary of the infrastructure here. Indiana University is the major site, the player that has the largest chunk of infrastructure here. They have 416 of these virtual machine nodes hosted there. They have 90 nodes that have 4 A100 GPUs on them each. They have 15 petabytes of data. So this is a computational resource that is available to anyone across the nation, especially if you have NSF awards. And we also have a small chunk, a regional chunk here at the University of Hawaiʻi. So we have about an 8-node cluster with about 2 nodes that have 4 GPUs each, so 8 A100 GPUs on that. So it's not super big for the region, but we do have some that's can be local. So if data locality and latency is an issue, we can work with getting you allocations on the piece of Jetstream that we have here. And we actually leverage this for Change Hawaii because we have acquisition processes that are running at Indiana, and we're putting in backup acquisition processes to run regionally here. So we're across 2 different cloud regions. So just like AWS or Google or Azure has different regions, Jetstream has regions, and they experience different connectivity. They're in different data centers, so we can distribute these things so that we have a more robust data acquisition system. It's really simple to access. You just go to jetstream-cloud.org and go there. But before you do this, there's 2 things that you require. Access ID. So Access is the program that replaced the extreme science and engineering discovery environment, which is called Exceed, that was around for like the last 10 years. That was basically the kind of consortium of large advanced computing resources that you could access with kind of one account. So Access is the next evolution of that. And so you need an access ID, and you need an allocation on Jetstream2. So getting an access allocation, it's actually not super difficult. You used to only be able to kind of do it every quarter in the old Exceed system. Access now has a really low level tier called Explore Access. You fill out a form that basically has, what's the title of what you're doing, write me a couple sentences, upload basically like a 2 or 3 page CV of who you are and why you're going to use the resource, and you submit that along with a request for some amount of resource. And you can request about $40,000 worth of cloud resources and get it approved within just a couple of days, and then get on to doing what you need to do. The Access ID is super easy to get. It integrates basically with we're incorporated with InCommon. So the University account Hawaii works with the CI login system. So you can link an account or create a new account on Access and create it. So it's really simple to do. And with that, I will go right into doing a demo of Jetstream. So Jetstream, log in on the page, simple, easy. It has single sign-on, so I already logged into a session, so I just passed right through to this interface. So this interface here is called Exosphere, is the user interface. It's very easy to use. The little boxes that you see here, these cards, these are the different allocations that I have within Jetstream2. So I have allocations for some Change Hawaii allocations that actually I brought over from the previous EPSCoR. I have one here for basically this workshop, and I have some others for that I'm gonna work with Jason and Maddie on Sage 3. Some folks, a researcher over in Guam who's trying to work with Jason on doing some drone photogrammetry stuff. So Dr. Ramona King, to get her access onto some of the GPU resources since they don't have some of those things over there. So anyway, these each represent my allocation. So I can go to one of my allocations here, the one I specifically set up to do some workshops. And then I get this sort of view here of how many service units are in my allocation. So this is, how many CPU hours or storage units or GPU hours that I have to leverage within Jetstream, and how much I burned down. So I haven't used hardly any of it. You see, I've only used 1,000 here. How many virtual machine instances have I been running? So I can have 2 of 25 within my current allocation. You can create storage volumes to attach to your VMs. So you can set up your virtual machine with some base level of storage, and then you can add additional storage volumes to it. And then for each of these, you can have public IP addresses. So if you want to set up like a Jupyter Hub or an RStudio to share with other people, like in the typical way across the internet, or set up some kind of application that can work and be accessible via an IP address in a browser or over SSH, you get assigned a public IP and you can access the system that way. So anyway, I'm going to show you, how to create an instance real quick. There's a create button here. So within my allocation, I'm going to create a new instance. I have a couple choices here. So I can choose some base images that have, they've got basically 2 Linux operating systems. Well, I guess they have a couple different ones. So they have Ubuntu-like, so Debian operating systems, and then they have Red Hat style systems. Rocky Linux is the latest kind of iteration of CentOS. So you can select any one of these. There's also the opportunity to create other images. So you can actually snapshot your own images. And if you want to, have different VMs for people in your lab that have the same software installed on them, you can snapshot those images, and then they can show up here within your allocation, and other people can create instances based off of something you've created in the past. So we'll just really quick set up an Ubuntu image. The process is really easy. Now that I selected the operating system, I can just give this a name and just call it my test VM2. Then I just choose how much the resources is. So I choose what they call it the flavor. So there's M3 tiny. So this is like 1 CPU, 3 gigs of RAM, 20 gigs of disk. Or you can choose an extra large machine here, which is 64 CPUs, 250 gigs of RAM, 60 gigs of root disk storage. Very easy. I'll just spin up a small machine here that's going to have 2 cores. The default size is 20 gigs. If you want to customize it, say I want 30, I can just change that there. If you want to spin up some kind of cluster, you can do that too. So I could spin up to 10 of these machines at once just by moving this slider, and we'll create 10 of these virtual machines. If you want to access this with a web desktop, you just click yes, and you can do that. And those are all the choices I need to make. And now basically I hit create. It's building a virtual machine for me with 2 cores and a couple gigs of RAM. It tells me how long it builds. It just takes a couple of minutes to do that. But much like the cooking shows, I'm just going to go to one that, we already waited the time for it to happen. So here is what the interface looks like for a virtual machine instance. So I go into this example desktop instance. So this is a web desktop one that I set up previously. You get some monitoring to see, how much of my CPU am I using? How much memory am I using? So I have 2 cores, 6 gigs of RAM on this, and 20 gigs of storage that I added here. The way to interact with these things, you can actually just go through the web browser here in Exosphere. So I can access a shell session through web shell, or I can access the desktop right here. So if I want to click that, it opens up a VNC session within the web browser. And then I have a desktop here. So I have a GUI desktop on this virtual machine that just took a couple of minutes to spin up. By default, there's some shared software on here. So RStudio is already on this machine by default. So I can just click that, and now I have RStudio running. There's MATLAB already on here. There's a couple other pieces of software that are just kind of shared on the virtual machines by default. Your user, you automatically get root level access on the virtual machine, so you can install and do whatever you want on this machine. You can add other accounts so that people can access it. If we go back to the instance here, the way to access the machine, so the credential information is this card here. So there's the public IP address that I can use to SSH into it. It gives me a default user every time. And then there's a passphrase, which, I can hit show or hide to be able to access this. And then if I want to add public key, SSH keys to do that, I can do that. I mentioned the web shell is also another way here. So via the browser, now I'm in this VM just totally via the web shell. There's some handy things you can do via the web shell here. You can upload files if you would like to via this interface. You can just click on the devices here. You get your file browser here. And I'm in my homes directory as this EXO user. You can just click upload files. Let me upload a research.gov thing I did earlier. Uploaded it. Can exit out of that, and then I can list in. There's the file. So this is a super simple way to spin up resources that you can have these things to live as long as you leave them up until you basically run out of allocation. And your allocations are good for about a year. So other things that you can do with your VMs, if you want to keep your allocation and not waste resources, like if you're not doing anything on this and you don't want to waste a lot of resource, you can suspend your virtual machine, and it kind of it saves the execution state of this, and then it kind of decreases how much SU it's using at the time. Or you can shut it down and shelve it, and then you can bring it back. You can unshelve it later and bring it back online when you actually want to access it. So you can spin up a bunch of different virtual machine environments to do whatever you kind of need to do. Or like I said, you could create a snapshot of this image, and then other users in your lab or even yourself, you can spin up additional instances that have all the same configuration and software that you installed on this virtual machine. If you find that you need more resources, you can on the fly resize your virtual machine. So if I am no longer satisfied with 2 CPU and I want to go to 32 cores, I can just click resize and it just does it. And that's a pretty cool feature. So this is a way simpler interface than trying to use Google Cloud Platform and some other of the commercial clouds. So they've done a really good job with making this very user friendly. And if you want to add other people in your lab, you basically just you would go to access and you would add them to your allocation. One thing I forgot to mention with access, Jetstream2 is not the only thing here. There's a ton of other resources. So here are all the other resources that are available within access that you can get allocations on. In particular, for a lot of the data science folks, the new NCSA Delta GPU cluster is of interest because they have about 100 compute nodes that have 4 A100 GPUs on them each, and then 100 that have 108, that have 4 A40s on them each, and then a couple that have 8 A100s on them for doing really large NVLink type compute. But this stuff is basically you just fill out the short allocation and you can get a starter set up on these things. So I think we're kind of at the spot where we're at time, but